Hello, this is Hazel from C-Trax Customer Support. This video explains how to create a primitive for use in the Excel Designer PCB CAD software. Primitives are used to represent power symbols or power connections on the schematic sheet, and they can be incorporated into split library parts. A split library part is used when a part has got multiple elements that are not all the same. For example, a relay which requires a coil and a separate contact symbol. Or perhaps when you'd like to show the power pins on one gate of a package that does have similar gates. For example, an op-amp might have two gates and you'd like to show the power pins on one of them. So that would be defined using a split library part. I won't be covering adding or modifying lines, terminals and so on, as this has been covered in the video tutorial on schematic part creation. In order to create a split library part, we first need the primitive that will be used within it. Here we will create a relay which has a coil and two sets of contacts. So we will create two primitives, one for the coil, one for the contact. I will be working in the job that we used previously for the part creation exercise, but you could be working in a new job or an existing job. So once it's opened, we go up to the navigator and expand the job, and then the schematic folder, and in the primitives folder you'll see the power.2 symbol we created for the previous exercise. I need a new primitive, so we right click on the primitives folder and select new, and then we give it a name. So this is going to be the coil for the relay, and then double click to open it up. On the screen in front of you, you see the default part ident, which is $NNN, and the default value currently set to null. I've expanded the screen and we'll just press F4 to centralize the attributes, and then we'll draw the symbol around those attributes. As we did previously in the part creation exercise, we look at the symbol attributes, and the only thing we have to set in the primitive is the value field. The important thing when setting the values for primitives that will be used in split library parts is to ensure that the value fields are identical between the primitives that will be used within the same split part. Now we see the value field appear. First thing to do is draw the outline for the symbol. Then add the terminals. And then tidy up the symbol by moving the attributes and hiding the attributes that you don't require. At this stage you can define the logic type on the pin. So attributes pin, and check that the datum is in the center of the component, which it is because I drew the outline around the datum. So that's the coil for our relay created as a primitive. So now we move on to the contact. So we create a new primitive, right click new, and open it up to the symbol attributes, and provide the same value field that we provided for the coil. As mentioned before, it's important that the value field on all the primitives you use in the split part are exactly the same. This time I'm going to add the terminals first and then draw the outline to fit around the terminals. Hide the attributes I don't want to see. And move the others into their approximate positions if we're not exactly sure where they should go. Now add the outline. I'm going to zoom in to get some finer detail for the little arrows. We can assign the logic type to the pins once again. Check the datum is in the centre of the component, which it is, and that's the contact complete. You'll notice that on the coil and the contact we haven't assigned any pin numbers because the pin numbers will be assigned once the primitives are brought together in the split library part. Now we are ready to create the split library part. So from the schematic folder we right click on the split parts folder, new, and provide a name, and then open up the part. So once again we go to the symbol attributes, we specify the prefix for the part, which will be RL for relay, the outline that's going to be used by this particular part. We can use a DIL 8 because it's got 8 pins, and this is my own relay, not one that you can actually go ahead and buy. And CTRAX order code, and you can also put a link into a data sheet on the internet or on your hard disk if you want to. We now add the primitives that make up the part. So we need a coil, so we use the sub symbol place command and then choose the primitives that we want to use. So we need 1 coil and 2 contacts. Now it doesn't matter where you position these symbols on the screen within the split part because they will all be added individually to the circuit diagram when you use them. And now we're ready to assign the pin numbers to the terminals. Obviously you have to get the correct pin numbers for the part you're making. Just a bit of random pin numbering allocation there. You obviously need to use the correct pin numbers for your particular part. If there are any pins that are electrically equivalent that we will be able to swap, then we need to define those now. You choose a colour and then which pins are equivalent. If I zoom in a little bit you can see more clearly. None of the pins on the contacts are equivalent, so we would just leave those as they are. But what we will be able to do on the artwork is swap the 2 contacts with one another because they are electrically equivalent. So it's the sub symbol swap rules command. In the dialog bar you can see we've got the coloured boxes, and at the bottom you've got the local and global settings. So if you want to allow just the two contacts to swap within the part, you choose the local option, but if you allow them to swap with any of the other same parts, you can choose the global setting. So we'll choose local, choose one of the coloured boxes, it really doesn't matter which colour you choose, and then choose the gates that are within that same grouping. Then the last thing to do in this particular part is to run the terminals check command. And this will tell us whether we've duplicated any pins or we haven't assigned any pin numbers. And it's telling us that we've got 8 normal pins, no power pins and no error messages. And that's exactly what I would expect to see on this part, because we've got 2 contacts with 3 pins each and 1 coil with 2 pins, which adds up to the grand total of 8. So that's our relay complete. Now I'll just explain how you use your split parts on the schematic sheet. If we go across to the navigator, you'll see the split part folder and the relay that we created, and it now shows that it's got 1 coil and 2 contacts within it. And normally if you're going to draw a circuit diagram, these folders won't be expanded, so I'll just close them up a little bit so that you're in a normal working situation. So we need a new schematic sheet and open it up, zoom in, and then we're ready to place the components. So let's assume we want to use the relay. So we use the symbol place command, move across to the navigator and expand the split parts folder where you've got the relay, which we expand, and then you just choose which symbol it is or which primitive it is that you wish to place. So we just position the relay where we want it. We can add more if we want them, or we can move across and choose a different symbol, and we'll just add the contacts. The contacts can be placed close by the coil or across the other side of the sheet or on another sheet. So what I'll do is I'll place 3 sets of contacts down, and then we'll allocate them so that you can see what happens. You would connect up to the split part in the normal way. So we use the allocation and automatic allocation for the current sheet, and you can now see, if we can center the symbols on the screen a little bit, we've got RL1A with the coil, RL1B for the first contact, RL1C for the second contact, and then because there are only 2 contacts in the relay, the next set of contacts has been labelled RL2 with the associated pin numbers. So that's how you use a split part on the circuit diagram. So what I'd like to show you now is how to use a primitive that will represent a signal name. We'll have a look at a circuit diagram that already uses a signal name primitive. And here is a ground symbol made up from a primitive. And then if we look further up the schematic, we've also got a symbol representing the VCC. Alongside it we've got an ordinary connection which has just had a signal name assigned to it. So if you use the V+ signal name a lot, you might like to make up a symbol primitive for it. The advantage of using a signal name primitive is that you don't have to spend any time typing in the signal names, which might lead to typing errors, and it makes the schematic easier to read. When the parts and wiring list is extracted in flattened mode, then all like named signal names are automatically joined to one another across sheets without you having to do anything. If the netlist is extracted in hierarchical mode, then all signal names are local to the sheet in which they reside, unless they have been defined in the power names table, at which time they become a global connection. To maintain connectivity across hierarchical sheets, you have to use block I/O ports, and that will be the subject of another tutorial video. So I will just close the open windows, return to the original job and expand the primitives folder so you can see the primitives that we've already created, and we're just going to add another new one. So right click, new, and we'll make a symbol for the V+ signal that you saw earlier on. I always give my signal name primitives that will represent signal names the same name as the signal name to which they will be attached. That will avoid any confusion later on. We're ready to open up the primitive for V+. We'll center the datum on the screen, and the first thing we need to do is draw the primitive. Add a terminal. And now we can see the attributes. I pick them up and move them so you can identify what's what. The only attribute that we need for this primitive is the signal name attribute that's assigned to the terminal. So I'm going to hide all the other attributes and then select attributes pin followed by the terminal, and you'll see now that we've got a new attribute called signal name, and that's the most important attribute on this primitive. So we open it up and we assign the signal name that this primitive will represent on the sheet, and I would suggest we make it visible as well. You can specify the logic type if you want to. And now we've got the V+ signal name attribute visible. If you want to make it bigger, you can just edit the attribute. And move it into position wherever it is you'd like it to appear. And that's that symbol defined. When you'd like to make another signal name primitive, all you need to do really is to copy one that you've already defined by right clicking, copy, and then right click on the primitives folder and paste, rename the copy, and make sure that you open it up and make sure you change the signal name attribute on the terminal. And now this one will be called +12V. Everything else has been done on the symbol, so that's that one complete. And you can just make up as many primitives with signal names as you like. The signal name doesn't have to be a power rail, it can be anything. You could make up a little clock face and call it the clock line. So any signals that you use commonly, make up a primitive for that signal name to save you typing. And then if we go back to the schematic sheet, and let's assume we're going to connect our coil up to the +12V rail. So we use symbol place, add the +12V symbol, and then just make a connection like that. And when we extract the netlist, you can see we've got a signal name called +12V joined to RL1 pin 1, which is exactly what I've drawn. We have got a warning that it's a single node net, and that basically means you've got a connection that's starting somewhere but then doesn't go to anything else, which is exactly what we've got here. So that concludes this video. You should now be able to create a multi-element schematic part where the elements are dissimilar symbols, and also how to create a primitive for connectivity. I hope this video has been informative for you, and if you would like to get in touch with us, please feel free. You can find our website at www.ctracks.com. Thank you very much for listening, and this is Hazel signing off. Bye.